In the last video, you became experts at the Perceptron, the linear binary classifier. We learned about the model, the math behind this Perceptron, and then we made our own Python-based Perceptron algorithm using NumPy. So in this video, we're gonna shorten that code. We'll make the Perceptron, but we're gonna use a widely known Python library called SkLearn or Scikit-learn, which is gonna make making the Perceptron a lot easier for us. And you'll get to see what I mean. After we learn how to make the Perceptron in an easier fashion, we're going to talk about some of the shortcomings of the Perceptron. Mainly one of those shortcomings being that it is a linear algorithm. So if data points are kind of organized in a different way, it gets really challenging when we're talking about terms of classification and things like that. But there are other models that can do better jobs at classifying than the Perceptron. And so towards the end of this video, we'll talk a little bit about another model, which will lead into a future video about that model and what that model is about, and of course making that model. Let's jump into the easy version of coding the Perceptron. Okay, here we are back into our Google Colab environment. I just opened up a new Colab notebook. We'll call this one Perceptron, and then we'll call this SkLearn, because we're just going to make a very simple Perceptron with the SkLearn library just to show you how easy it is, of course. Now we're going to use a different data set this time. We're going to use something called the iris data set, which is iris flower. This is a 3-class kind of model where you have 3 different classes of the iris flower, and the Perceptron is going to make predictions based on given input on which of the different classes of the iris flower that the categories, or we'll say features, belong to. All right, so to start our code, we need to start with our imports. So I'm going to import sklearn. Well, actually what I want to do is from sklearn, I want to import dataset, because sklearn is a library that has a suite of tools. One of those tools happens to be built-in datasets. So we're going to utilize one of their built-in datasets, and I'll show you how that looks afterwards. And then I want to import NumPy as NP, because we're going to use NumPy for these things. And for now, let's also import pandas as PD. We'll come back and add our other imports as we go, but for now, this is what we kind of need to start with. Okay, from there, I'm going to add a new code block, and here we're going to actually import our dataset. So we're going to import the iris dataset from NumPy. So in order to do that, we need to identify here. Of course, Colab loves to help us out with this, which is what I do like. And yes, we're going to load iris, and boom. Now we have our iris dataset saved in a variable called iris. We can look at this in a second. Let me just assign variables to this iris dataset. In this case, we want to utilize 2 features. So we want our x. X is going to be the features. So not the label, the features that are used to help with classifying in the label. The x is going to be, we'll say iris data, and we want pretty much all of the rows. So this colon here would be all the rows, but we only want columns 2, or in this case, column at position 2 and position 3. So of course, in Python, we start at 0. So this would be columns 3 and column 4. So x would be the features at column 3 and 4, and y will be our target label. So y is going to be iris.target. And of course, sklearn makes it easy. All we have to do is specify target, and sklearn knows to focus on the target label, which would be iris. Now, before we import the iris dataset, let's look at our dataset. Let's give it a look and see what we can do here. So in order to do that, we have to create a data frame from that. So in order to create a data frame, we'll call this, we can just call this df, or data frame. Fine. And that's going to be PD data frame, of course, and then Colab loves to fill it out. So we're going to actually have the data of that data frame be iris data. So equal sign there, and we want iris data. So we just want to see the data inside the iris data set. Columns, we need to specify, and that's going to be the iris feature names. Of course, Colab gets it right this time. Boom. And then we want to add the target column. So the target column, I am very familiar with the iris data set. So the target column is actually going to be called species, which is a species of flower. So in order to do that, we just do df, and we need to specify that target column, which is species in this case. And that's going to be equal to iris target names. There it is. I for I and iris target. So that's what we kind of need. So, and close that brackets. There we go. So this is going to be a target label, and the target label is going to, be either one of 3 different options. And then we want to output that to a CSV. We'll say to df to a CSV. There you go. And then iris CSV, but we'll also say index equals false. I want to specify a specific index. All right, so running this, we'll start at the top. We'll load our iris data set. Okay, we're getting error here because I don't have a comma after the colon. Typo no early typos. Now let's try it again. There we go. Now if I run this, we should have a data set created right here on the iris CSV. So we can download that, can open, and we get to see some of how the iris data set looks. So as you can see, we only want the 2 columns at positions 3 and 4. So we're only going to take these 2 columns, which is the petal length and a petal width. The species will stay the same. The species is our target label here. So this is the iris data set. Very simple data set, only about 151 rows, and good for classification, especially for examples. I'm going to close out of this. All right, and we'll continue our code. We actually don't need this. That was just to take a look at the data set. We can continue. Now we have our data set loaded in this variable iris. We're going to get to the, I call it the easy stuff. Okay, so in this case, we could print our labels. So let's just do print, and we'll look at the different labels. So NP unique, and that's going to be Y. We're going to look at the Y labels here, and as you can see, there's 3, 0, 1, and 2. Those are the 3 different classifications already pre-encoded with SkLearn for the iris data set. So that was the 3 that we saw. All right, let's keep going. So in this case, we want to still split up our training data and our testing data. So how we're going to do that with SkLearn will be, we'll say define training and testing data. So how we're going to do that, we're going to xtrain, and we'll say xtest, and then ytrain. We're going to just specify that all here, and ytest. That's going to be equal to train test split. That's what that's going to be equal to. So we're going to obviously train X, which is already defined up here. So all of our features with Y, the target label, right? And then the test size that 70-30 split. We want to have the, in this case, we'll do 30%. So 0.3 of the test size. That means 70% is reserved for training and 30% is for testing. And then we add our random state so that the random state can be saved. In this case, we'll keep 1. Why not? And then stratify. We do want stratify to be equal to yes. Stratify basically turns the training and test subsets to have the same proportions of the class label. So it keeps the class label proportions the same. Now, because we use train test split, which is an SkLearn library, we actually need to import that library. So to do that, we do from, looks like Google Colab already did it for us. So from sklearn.model selection, import train test split, straight from the SkLearn library. Nice and easy. All right, now that we have our xtrain, xtest, ytrain, and ytest defined, we can insert a new code block and we can move on to the next steps, which in this case would just be specifying our scalar. So the scalar being how the data is scaled, of course. In this case, we're going to continue using the standard scalar. So I'm just going to specify that as a variable, standard scalar, and then that's going to be equal to standard scalar. And we'll do it like that. Boom. Now, since we're using the standard scalar, again, with sklearn, we do have to import the pre-processing scalar. So from sklearn pre-processing, import standard scalar. That's what we're using here. And then from there, we need to start doing our pre-processing to the data. So what we're going to do is standard scalar.fit xtrain. So standard scalar.fit, what this does, it applies standardization to xtrain. Standardization is pretty much processing the data on a scale from 0 to 1, where 0 is the mean and 1 is the standard deviation. We'll get more into that in a little bit, but just know for standardization, you're kind of, we'll say, constraining all the data to the scale from 0 to 1. So that's what we're doing here with the standardization. Okay, once we do that, we actually need to transform the data. So apply that standardization to the data. And to do that, we're gonna start with xtrain, and we'll follow the Colab way. Xtrain standardization, that's standard scalar.transform xtrain, and then we have xtest standardization, standard scalar transform xtest. So now we are, we'll say, using standardization scalar, and there we go. Really quickly, just so you can understand how standardization and standard scalar works and what the xtrain standard deviation is supposed to mean and things like that, and the scale of 0 to 1 with the mean and the standard deviation. Let me show you how that might look or might be represented in a graph format. So when we talk about standard scalar, mean, standard deviation, all that jargon, we'll say, we're really talking about something similar to this graph, right? So let's say we have a population of people here in this graph here, and we're classifying something with this population. So let's say we'll classify the amount of hair that people have, for example. We can say over in this section here, right, few people have hair, and we'll say by age. We'll classify by age. So the youngest will be 0 and the oldest will be 2. In this case, we'll say 0 has relatively no hair, but as a child grows up, they tend to get more hair. But then when they get too old, right, when they become, we'll say, elderly, they start to lose their hair. So let's say that's how the normal classification would look like. What we mean by standardization is we're going to take the mean. So the mean is here, this mean value, and we'll set that to 1. So the maximum, right, which would be the mean here, this mean would be 1, this maximum number here. Now, standard deviation is the space in between the mean, and we'll say there's multiple standard deviations. So this will be standard deviation 1, there could be standard deviation 2, deviation 3, deviation 4, but anything that deviates from what the populace says. So in this case, the populace is, most people have hair when they're in between that age range, right? So not too young and not too old. Standard deviation 1 would be that first deviation from, people who have, a good set of hair. So on this end, we'll say that's roughly about 0.5, right? So that'd be 0.5 of a standard deviation here. And then on the other side, we can say also there's a 0.5 standard deviation there. So that's what we mean while we're taking the standard deviation, that this essentially would be 0.5 if we were going by that. But that's how standard scalar works in a nutshell. Okay, let's get back to our code. Okay, now that we know how standard deviation works, we can understand why we're using standard scalar and what the standard scalar is doing with our code. And now we can move on to the next steps. So now that we pre-process our data, you can see it's getting a lot easier as we go. We only have a few cells here and we're actually almost done with the classification. So next, all we have to do is actually instantiate our instance of the Perceptron. So we'll call that Percept, short for Perceptron, and of course Perceptron here, and we're going to set the learning rate at 0.1. I think that was what we set it at last time, and we want the iteration, we'll do in iter, and we'll set that to 100, and then the random state we want to be 1 as well here. All right, and also we want to fit our data, the new data we have, the standard deviation data, into our Perceptron model, and Scikit-learn allows that with its own libraries. So xtrain, and right there, xtrain standard deviation and ytrain. So Scikit-learn has its own library for the Perceptron. So we're going to go up here and we're going to actually import that. As you can see, Google Colab already knows. So we're going to import Perceptron, and then SkLearn is already importing the accuracy score because it's already predicting that we're going to probably want to print out our accuracy, which we will. So what we're going to do is in the next line, we're going to actually set our prediction. So we'll say y prediction, which is the output of the Perceptron. And this is going to be equal to our Percept, which is here, and predict. So we just want to predict based on the features that we have for X test standard deviation. So our test set is what you use to predict. And then here we want to actually print our accuracy. So we're going to print, and we'll call this accuracy, and that's going to be the accuracy score. We want to print out the confusion matrix and classification report, which we could do if we want. We don't necessarily need to. For this example, we're just going to do accuracy. So we're going to print out the accuracy on Y test and Y predicted, and we want to see how well the predictions are evenly aligned with the test data. All right, let's run this, and then we'll move on and see if we can graph this data. So we need to start at the top and do our imports again. Just go down the list here. There we go. And we can use standardization scalar and pre-process the data. Now we're going to try to fit it. Got keyword ETA. Did I do something wrong there? Yes, I did. So ETA should be ETA 0 based on the syntax of how the Perceptron class is instantiated, and iteration. So let's remove the iteration here because I think there's a certain amount of iteration that's built into the Scikit-learn library. There we go. So this is our Perceptron class that's instantiated, and now we can see the accuracy that it gives us. There we go. So we see we have an accuracy of 0.97, which is a pretty high accuracy given the data set that we gave it in the 2 features. So the Perceptron is doing the binary classification relatively well for selecting iris plants, as we can see. We can also see it's a lot less code that we had to use. We can even minus this code. This was just to look at the data set. So we'll take that out. As you can see, there's not that much code that we have in order to get our accuracy. And of course, we can utilize graphing as we did in the other Perceptron development. So what we'll do for our classes is we can import matplotlib once again. So in order to do that, we'll do from matplotlib colors import. Yeah, we'll do that. And then, so yeah, we'll do those 2 here. Now, again, just like in the last video, I'm not going to go over the plotting code. I am just going to kind of paste it over. But if you would like to play with this yourself, this will be on GitHub. I will share the GitHub link in the description, and feel feel free to play with these as you like, and even play around with the iris dataset and see if you can, instead of using the features 2 and 3, check out the features 0 and 1 at index 0 and 1 and see how that changes your accuracy and other data. So bear with me 1 second as I paste this data. Okay, we are back with our graph data pre-pasted here so that you can see it. Let's run it and see what we're looking at. Listed color map is not defined, so we actually didn't run our imports again. There we go. Now we run our imports and this should work. Boom. Okay, so as you can see, there are 3 different classes. So in this case, as far as the linear lines, you see 3 different lines. You see the linear line here, the linear line going down, and then the linear line, going here. And these are kind of set up into 3 different sections, we'll say, the blue, the red, and the green. And as you can see, there's green being classified, blue being classified, and red being classified. These are the 3 different flowers, iris flowers, that are being classified by the Perceptron. We can call these data points if we were to try to figure out what these shapes are here. So the way that this kind of works is the Perceptron tries to draw a line through the data. We'll call it like the best fit line, and based on how the points are in comparison to that line, it makes some classifications. So in this case, as you can see, there are some triangles that kind of cross over to the blue quadrant. There are some blue that kind of cross over to the red, and then there are also some blue that cross over to the green. So this shows that the prediction isn't 100% accurate, which is how we have that high accuracy of 97% instead of 100%. But as you can see, for the bulk majority of things, the Perceptron did classify this really well, and it was able to determine the iris plants really well. So that's how you would read this graph. Okay, and we just made our Perceptron really easy with SkLearn, just a few lines of code, and that's pretty much about it. Let's talk about some of the cons of the Perceptron. So we talked about the Perceptron quite a bit, but we haven't talked about one of the shortcomings and why we start using more advanced models instead of the Perceptron when we're doing more advanced classifiers. So we'll take this example. This example is a classifier for the speed of a car and the distance taken. The green bubbles are data points. So these data points correspond to the speed of a car and the distance that car has taken. So in this case, we can clearly see that we can draw somewhat of a linear line through these data points. We can call that the line of regression or the best fit line. And that line will essentially help the Perceptron to classify these data points, one being on one side of the best fit line or line of regression and another being on the other. This works really well, but what if you have data aligned a little differently? Let's say like this. Now with this data, it seems a lot harder to draw that linear line. As you can see, the classification isn't really equal, and as points on the graph here start to get more chaotic, so let's say we add some in the middle, we add some further off the x-axis, further off the y-axis, it gets more difficult to draw a best fit linear line. So this doesn't really work. But one of the properties that make the Perceptron even more weak towards data that's structured in this way is that you can't draw curved lines in a Perceptron. It has to be linear. So that's one of the main shortcomings of the Perceptron, where if you have data points in a classifier like this, it becomes difficult to classify that data. Now, there is a way to successfully classify data like this, and that's using other models that are not the Perceptron. But in this particular case, we can use something called logistic regression. And logistic regression pretty much uses logarithmic operations, of course, that seems to draw a curved line similar to this. Now this line, as you can see, now correctly classifies a lot of the data points here. So this would offer a much better prediction than our Perceptron. Logistic regression is a lot more complex than the Perceptron, but the building blocks of logistic regression is very similar to the Perceptron, where you give it a bunch of input, it goes through some kind of activation function, and then you get your output. We're going to look more into logistic regression in the next video, and then we'll go and make our own logistic regression model so you can also see how the logistic regression works. Then we'll start talking about some challenges in machine learning, one being choosing the right classifier for the right data. One of the biggest challenges that machine learning analysts, data analysts, and anyone else working with machine learning goes through, and you will probably too if you decide to get into the space of machine learning. If you like this video, make sure you like the video, comment below what you think of this series, what you'd like to see. Don't forget to subscribe, and remember, when I win, you win. That's what this is all about. Tap out.